Hi everyone. So previously we were done with the graph-based algorithms, man. Yeah. Um, Now today we'll be starting the this one DP algorithms or DP-based algorithms. First we'll be starting with the longest common subsequence uh, algorithm, basically the most common one of the most common algorithms within the DP, right? So let's see what the definition part says here. So the longest common subsequence LCS between two sequences is the longest sequence that appears in both. Longest sequence that appears in both. See, they have also said that not necessarily contiguous, right? Not necessarily contiguous means it can be continual or non-continual as well, right? So this is fine. Now LCS is typically solved with a dynamic programming n big of n into m, nothing but longest common subsequence is typically solved with dynamic programming n big of n into m time, where n and m are nothing but the lengths of the two string and big of n into m space. So time complexity and the space complexity for this particular algorithm will be big of n into m and big of n into m respectively. Yeah, let's get into the explanation part. So we what we do basically, we build a 2D DP table. As we are going with a this one dynamic programming, first we will build the 2D DP table. And one more thing, we are doing this one at the right time, we are also solving the dynamic programming this one problems, some of the problems in the LeetCode. Actually we solved around 50 problems recently, the Codeforces problems, actually the dynamic programming, where we covered most of the important topics. There we had this one used most of the important algos as well, right? Yeah. So we are solving currently we are solving some of the most important problems in the dynamic programming problems in the LeetCode. Currently we are solving 2D DP problems itself, so this will be helpful if we understand, right? So we build a 2D DP table here, 2D DP table DP, where DP of ij is nothing but the length of the longest common subsequence of the prefixes a of I, this one, and b of, so recurrence, so we can write it in this way. If a of I minus 1, if it is equivalent to the b of j minus 1, so dp of ij is nothing but recurrence, we know, man, dp of I minus 1 j minus 1 plus 1 will take the matched character, right? So we'll consider only the, or we'll take the that matched character basically, right? Else dp of ij equals dp of I minus 1 j dp of ij minus 1, meaning we will skip one character from a or b, right? So the exact thing that will be implementing in the form of code, right? So within the algorithm, yeah. So after filling the particular table, we can reconstruct one longest common subsequence by tracing back from dp of nm to dp of 0, 0. Yeah, this is fine. Now let's write the algorithm. Let's write the algorithm. Yeah. Now let's do one thing. When I say let's write the algo, I mean let's make use of the Python programming language, man. First thing here would be yeah. Let's start writing the algo. First, let's compute the LCS of the two strings and let's print the length and also one longest this one common subsequence. Let's do that. Yeah. So again, let me tell you one thing. What we'll be doing here, we will compute or calculate the LCS, longest common subsequence of the two strings, and we will print the length along with the one longest common subsequence. Yeah. So just let's start writing the code. So this one will be def LCS of a comma b. So this is fine. So within the LCS, so first step would be let's create the DP table with length of a plus 1 into length of b plus 1, and then this one initialized to 0, right? So this one I'll just consider length of a, as I've said, and also yeah. So this one will be going with the n into m, right? So this one will be length of b. Simple. Now let's go with the dp of ij is equivalent to the LCS length of a of 1, this one, b of this one. Where did it go, man? This one, right? B of j. So this one, this is fine. Let's do that actually. Let's go with the initialization part. So I'll just go with dp 0 into basically m plus 1. This is fine for um, range. What's the range actually? N plus 1, right? This is fine. Yeah. Now this is fine, I believe. The next step would be, so we are done with creating the DP table with length of this one, length of a plus 1 into length of b plus 1. Also, we have initialized that one to 0, right? So this is fine. Now, the second step is let's fill the DP table using the bottom up DP. Yeah, bottom up DP. So as I've said, let's fill the DP table using the bottom up DP. Bottom up, by this time we'll be knowing actually, we should be knowing actually, bottom up uses this one. Bottom up approach uses iteration primarily, right? Primarily. So this one basically top down uses recursion, right? So let's go with the iteration. Let's go with the for loop here. So this will for I in range 1 comma n plus 1. This is fine. The next step would be we are iterating over the position in A, nothing but from 1 to n. Also, we have to iterate over the position in B from 1 to m. So previously it was 1 to n for A, and it would be 1 to m for B. So this one would be for j in range. So this one I'll give 1 comma m plus 1. So this is also fine, man. Yeah. Now let's do one thing. Let's go with a simple if condition, man. So let's go with a matching character set a of I minus 1 and b of j minus 1. So this one will be if a of I minus 1 is equal to b of this one. What do we call j minus 1? Then let's take the match. Taking the match in the sense. So this one will be dp of ij is equivalent to dp of I minus 1j. So this is simple. Uh, we are going with this one, right? So sorry, dp of I minus 1, to j minus 1 plus 1 actually. Yeah, this is fine, man. Yep, we are just taking the match. Else, else what we need to do, we have to take the best by dropping one character from either A or B, right? So this one will be if dp of I minus 1, if dp of I minus 1j, if it is greater than or equal to dp of I and j minus 1, this is fine. Then dp of ij, dp of ij equals, so dp of I minus 1 into j, dp of I minus 1 into j, right? Else, else what we need to do here, else I'll just go with the dp of ij, dp of ij equals dp of I into j minus 1. Yeah, this is fine, man. This is fine, I believe. Next, what we will do? Next, what we will do? So we are done with filling the DP table using the bottom up DP, right? So now let's reconstruct one LCS or the longest common subsequence by tracing back from DP of NM. First, let's collect the characters in reverse, man. So I'll just go with LCS characters. Let me assign this one to the empty array. Let me go with I, J. Let me assign I to N and J to M or initialize assign. So this is fine. Let's go with a while loop here. While loop while I greater than 0 and J greater than 0. This is fine. Next, what we'll do within the while loop, if A of this one I minus 1 is equivalent to B of this one. What do we call J minus 1? So this is also fine. This one is equivalent to B of J minus 1. So if condition we are going with, right? So this is fine. If the characters match, then this particular character is part of LCS, right? So I can just write it here, LCS characters. So this one, let me assign this one to the, so let's append, man. Why this flower bracket here? 1 second. So let's append. What we need to append here? A of I minus 1 actually. This is fine. Yeah. Now I equals I minus 1 as well as j equals j minus 1. This is fine, man. Else what we need to do? Else what we need to do? So we have to move in the direction of the larger DP value. So this one will be if if dp of I minus 1 into j, so this is fine. If it is greater than or equal to dp of I, this one, what do we call, j minus 1, then what we need to do here, I equals I minus 1, uh, then else j equals j minus 1. This is fine. Yeah. Now let's do one thing. Yeah. Let's do one thing. Let's go with a reverse to get the correct order. So I'll just go with LCS string here. Can't I consider string? Just go with a LCS string. We are going with the reverse to get the correct order, right? So just go with string dot join, empty string dot join. Let me go with the reverse keyword here. This is fine. I'll just pass LCS, this one characters, this one CHRS. This is fine. Now let's return the length and one LCS. Let's return the length and one LCS, the last part, right? So let me give here return. This has to be one LCS DP of N and M, finally followed by the LCS string. The previous line we have considered LCS string variable. This is it for the, what do we call, this is it for the code or the algorithm. Simple one, right? Longest common subsequence algo. Now let's go with the example usage, man. I'll just take that one from the Google. Just give me a second here. So here, so what we are doing, I have considered simple example. So this is nothing but the string A. This is nothing but the string B, right? Example string A and example string B. So this one length of length and sequence. So this is nothing but we are computing LCS here. So we are just calling the LCS function here, right? So this one LCS function. Yeah. Here we're just calling the LCS function. We are just computing the LCS in simple terms, right? So this print statement, we are making use of this print statement for the interactive purpose. First print statement, we are printing the input A. Second print statement, we are printing the input B. The third one here, this one, we are printing the LCS length. And the fourth one, we are printing one LCS string here. This one LCS string here, right? So this is fine, I believe. Now, we have understood the, this one, what do we call? Uh, what do we call here? This one, algorithm, right? So this one, longest common subsequence algorithm, clearly. So we are done with the algorithm. Let's do one thing. What is the output that we need to get here? Let's discuss the output and then later we can run the code. Yeah. Now, or I'll do one thing here. Let me run the code. Then I'll this one. What do we call? Let's discuss the output actually. I'll just give here Control J. This is slow man. Today, I don't know why. Python followed by the file name dot py. Yeah, we are getting the output A double G T A B GXTX AYB here. This is correct, and the LCS length 4 and this one, and LCS individual LCS that we are this one. What do we call this one? What we are doing here basically in simple terms, we are just printing one LCS string, right? So that is GTAB. We are getting the correct output actually. Yeah, see why, I'll explain you. So this one actually, whatever the output that we are getting here, string A double G T A B. We are just printing the string here. This shows the first input string that we use. So this one directly A double G T A B, and second one we are printing string B. So this is correct. So we are just getting here. We are just considered this string G X T X A Y B. So this is fine. These are the string. This one. Let's consider string one, and let's consider this one as string 2 or string A and B actually, right? So let me do one thing. Let me consider string A here, and this one let me consider string B. And LCS length is 4. Why the LCS length is 4? See, the DP computed the longest, the DP computes actually the longest common subsequence length, right? So which is 4 actually. So there exists a subsequence of 4 characters that is appearing in both characters, both strings actually. So again, listen to this. The DP computes the longest common subsequence length, which is 4. So there exists a subsequence of 4 characters appearing in both strings. 4 characters appearing in both strings. So these need not to be continual or contiguous. They have said this one, right? So I have said this one, I had stressed this one earlier, right? So that this one is G we are getting here. So this one we can, I'll just mark this in this way. G we have. So let me consider the first G actually. Yeah, G, G, this is fine. Then T actually, T is present here, T. Then A actually, A will consider this one, first one, A. Then consider, let's consider the B actually. So this is common in both. This is common in both GTAB and GTAB, right? So this is common in both string A and string B, right? One possible LCS is GTAB. Characters G, T, A, and B appears in that order in both strings, right? Note, we can have the multiple valid LCS sequences of the same length, right? So this algorithm reconstructs only exactly one actually, right? This can have again multiple valid LCS sequences of the same length. Yeah, this algorithm basically reconstructs one. So here GTAB is one of them that we are getting. Basically, we are getting the desired output, right? So this we are just printing the string that we have considered for the input, actually string A as well as the string B. LCS length that we got here is 4, and that one is GTAB is one of them. Yeah, you can clearly see I have shown that one correctly. Yeah, we are getting the desired output now. So we are done with this algorithm one, simple one. Yeah, this uses dynamic programming. That's fine. So now, as we are completely familiar with the algo, let's do one thing. Let me summarize whatever we have learned so far. Before moving on with the next algo, let me summarize whatever we have learned so far. Just try to remember these 4 to 5 points, man. First thing here is LCS finds the longest sequence that appears in both strings. We know this. Yeah. So it uses dynamic programming with dp of ij equivalent to LCS length of the prefix a of I and B of I. We know this one. Yeah, this is fine. Just give me a second here. This one, A of the first point. Yeah, this is fine. The dynamic, it uses dynamic programming with dp of ij equals LCS length of prefixes a of I, b of j. So this one, this is fine. Time complexity would lead to time and space complexity. We have already discussed. I'm just summarizing here. The time complexity and the space complexity both would lead to big of n into m, right? And it can be reduced to big of min of n comma n if you only need the length, right? If we only need the length, in that case we can reduce the time complexity to big of min of n comma n. Just remember this. And to retrieve the subsequence, right? So to retrieve the subsequence, just not the length, we have to keep the full table and trace back from dp of nm. So that's what we have done, right? So here we are getting the this one GTAB, right? And yeah, basically this is the thing. So these are some of the important points that I wanted to discuss. Yeah, just keep these things in the mind, man, along with the algorithm, right? Some of the important things that we considered, suppose for time complexity, space complexity, and other stuff. So what the algorithm mainly do. So these are the things we have to keep in mind anyway. Yeah, we are done with this algo. Next, we'll be discussing on the topic longest increasing subsequence algo. For now, this is it. Thanks for watching, guys.